Good morning, friends. Welcome to Water Resources Engineering class. In today's lecture, we will take up the same hydrographs unit, and in that, during the last 3-4 lectures, we discussed about what is a hydrograph, what are the factors affecting hydrograph, what are the components of hydrograph, what do you understand by direct runoff hydrograph, how to really calculate the depth of direct runoff. So what from a storm hydrograph, how to get the direct runoff hydrograph, that which we have done in the previous 3-4 lectures. So now in today's lecture, we focus on the key elements of unit hydrograph, and at the same time, what is the stepwise procedure for derivation of unit hydrograph, and let us see some problems in that. So this is the order actually in this particular lecture which we will take it up. What are the key elements of this? Already these key elements we have studied once when we studied hydrograph, but once again just brush it up. The first one is time to peak. Time to peak means actually from where you will take that, it is the time interval from the center of mass of the rainfall excess and peak of the hydrograph. Why you require that? It indicates the response speed of the watershed, how fast the water is reaching, the flow runoff is reaching to the peak. That is what the time to peak is very important. For smaller catchments, automatically this time to peak is very less, and very less, and similarly very less. Or if suppose steep slopes are there, then naturally this TP value will be very less, because for small catchments peak reaches quickly. Similarly, if intense slopes are there, peak reaches very quickly. So these are the two important things. Then peak discharge. The peak discharge means the maximum flow rate on the unit hydrograph, which is in meter cube per second. It indicates the intensity of runoff due to 1 centimeter rainfall excess. And what is the peak discharge? The peak discharge can be calculated as 2.778 into A by TB, is only an approximate principle where A is the area of the catchment in kilometer square, TB is the base of the unit hydrograph actually. What is rising limb? The increasing part of unit hydrograph from the beginning of direct runoff to the peak is what we call it as rising limb, and its shape depends on 3 important factors: rainfall intensity, slope and land cover. What is the falling limb? The recession limb means the decreasing portion from the peak, indicates runoff receding as water drains from the watershed, that is governed by the drainage characteristics and groundwater contribution. Please remember what are the factors that affect rising limb. What are the factors that affect recession limb? Recession limb, intensity of rainfall, no way linkage, no link. Intensity of rainfall, the slope of the catchment and how the land cover. These are the 3 factors which really determines how the rising limb is going to be, how fast the rising limb reaches to the peak. These are the factors. Whereas a recession limb means after the storm. That means how the drainage characteristics are, how the groundwater contributions are. These are the 2. Please remember, the storm characteristics does not have any hold on the recession limb. They are all influencing only the rising limb. So rising limb, falling limb, crest, peak discharge, time to peak, base time, time duration of rainfall, all that which we have studied previously, the same I have mentioned actually, right? Then coming to what is the area under unit hydrograph, right? Area under the unit hydrograph is nothing but it represents 1 centimeter of runoff covering over the entire catchment area. So kindly, it represents 1 centimeter of direct runoff over the entire catchment area. area under unit hydrograph is equal to 1 centimeter into area of catchment. Area of catchment multiplied by normally depth of direct runoff is equal to the whatever volume of water is there under this, or that is also represented by area of unit hydrograph. But unit hydrograph means that depth of direct runoff should be how much actually? 1 centimeter. That is the fundamental difference between a direct runoff hydrograph and unit hydrograph. Direct runoff hydrograph, same. It is only thing is the depth of direct runoff will be something like 3, 4, 5, 6 centimeters. Whereas unit hydrograph means that depth of direct runoff should be 1 centimeter. So all these definitions already we have mentioned actually. Again, direct runoff volume is equal to the area under the unit hydrograph curve gives the area under the unit hydrograph curve gives the volume of the runoff due to 1 centimeter effective rainfall. Since it is a unit hydrograph, the volume should correspond to runoff volume, area of unit hydrograph multiplied by depth of UH. So area of the catchment, area of hydrograph nai, this is area of catchment, please, multiplied by depth of UH, depth of basically depth of UH, that is 1 centimeter. Here you can write depth of runoff. The depth of runoff for UH is always 1 centimeter. So area of the catchment into 1 centimeter is the volume of direct runoff actually. So these are the things. Suppose if you come to this figure actually, first thing is the first one, if it represents actually, suppose for example, this one, if you see it, it is nothing but the direct runoff hydrograph. Direct runoff hydrograph. For this direct runoff hydrograph, what is the depth of direct runoff? The depth of direct runoff is equal to 2.5 centimeters. That is what we got. The moment I want to get a unit hydrograph from this, how can you get a unit hydrograph from this? Because if this depth of direct runoff is equal to 1 centimeter, then whatever ordinates are there, that is unit hydrograph. So this is the unit hydrograph actually. This is the unit hydrograph. What I have done, unit hydrograph ordinates are equal to direct runoff ordinates divided by depth of direct runoff. That's all. If for 2.5 centimeters, this, for example, for 2.5 centimeters, this is the ordinate. So for 1 centimeter, what is the ordinate? For example, for this is for 16 hours. So for 16 at 16 hours, this is the ordinate which we got, and this results in 2.5 centimeter. So what is this? Divided by 2.5. That's the linearity principle. Whatever is applicable, that's what I am explaining here. Now, what is the stepwise procedure to construct a unit hydrograph from a storm hydrograph actually, right? From a storm hydrograph to unit hydrograph. What is given actually? The given is storm hydrograph. What is required is unit hydrograph. This is the thing. Given a storm hydrograph, you want to find out what is the unit hydrograph. So first thing is collect the data and plot the storm hydrograph. That is what this. Plot the storm hydrograph, right? Then estimate the base flow. You have methods, different methods. Use the straight line method and separate the base flow. If you separate the base flow, what you are going to get? Direct runoff hydrograph. So first one is, this is storm hydrograph. Storm hydrograph. From storm hydrograph you have done what? Base flow. If you subtract this base flow, then what we are going to get? Direct runoff hydrograph. Then what is the step? Next step you have to do? Find the depth of direct runoff. How to find the depth of direct runoff? Yesterday I mentioned depth of direct runoff is equal to 0.36 into sigma O into T divided by A, that many centimeters. So find out. This is that actually. Once that is found out, how to find the unit hydrograph ordinates? UHO ordinate is equal to direct runoff ordinate divided by depth of direct runoff. That's all. Then you take basically time on x-axis, then the ordinate on y-axis, plot the curve. That is what your unit hydrograph is. Any difficulty in this? Given is what? Storm hydrograph. Next what you have done? Separate the base flow. Next what you have done? Then basically storm hydrograph ordinates minus base flow is equal to direct runoff ordinates. Once direct runoff ordinates you are obtaining it, then depth of direct runoff. How to get the depth of direct runoff? 0.36 into sigma O into T divided by A. Once you find that, then what you need to do? For so much of depth of runoff, this is the ordinate. For 1 centimeter depth of runoff, what is the ordinate? That is what unit hydrograph ordinates. So, unit hydrograph ordinate is equal to direct runoff ordinates divided by the depth of direct runoff. That completes the process. Very simple process actually. I will show you the problem. So, time is given. The storm hydrograph ordinates are given. In the problem, that fellow has given me base flow also. So, once base flow is taken, so observed flow minus base flow is equal to direct runoff. Is there any difficulty in finding out this? You have to, can you do it or not? This is given. This is given. The base flow is also given to you. Can't you find out direct runoff ordinates? Found out. Next what? What is the depth of direct runoff? Use the principle. Find out what is the depth. 3.78 centimeters. So 3.78 centimeter direct runoff depth. These are the ordinates. If 1 centimeter is the depth of direct runoff, what are the ordinates? That's the question. See, time, observed flow, base flow, direct runoff ordinate. So, what is the unit hydrograph ordinate? Direct runoff ordinate divided by depth of direct runoff. See the answers. This is 7 by 3.8, 20 by 3.78, 30 by 3.78, 23 by 3.7, 15 by 3.7 by 3.78, 3 by 3.78. Then I plotted unit hydrograph. This is unit hydrograph. That's all. The area under this, the area under UH gives you the volume of direct runoff. It is equal to nothing but area of the catchment into 1 centimeter. Here is a problem. The 6-hour unit hydrograph of a catchment is in the form of a triangle with the peak of 100 meter cube per second occurring at 24 hours from the start. The base is 72 hours. What is the area of the catchment represented by the unit hydrograph? Given is 6-hour UH. Base is 72 hours. Peak is this much. Suppose if I draw this. So, base is how much? 72 hours. Right? Peak is how much this? 100 meter cube per second. Given is what? 6-hour unit hydrograph. This peak is occurring at what time? 24 hour. So, this is 6-hour UH. Right? So, how to find what is the area? What is the area of catchment? That is the question. Area of catchment is how much? Let us think. So, the area under this unit hydrograph is equal to volume of direct runoff. Yes or no? Area under this unit hydrograph, area under unit hydrograph is equal to volume of direct runoff. Area under unit hydrograph, what is this actually if you take it? What is this? It is only half into C. Base is 72, right? Half into basically area of the unit half into base into, it is hours, so seconds he changed. By 100 he has put it actually, by 100 actually, you tell me what is that? Half base into height, this is peak, base height, right? Half base into height, so this is the volume. Again, volume of direct runoff is also equal to area of catchment into 1 centimeter, right? So area of this is all, this is this, and this is equal to area of catchment into 1 centimeter. 1 centimeter convert into meters actually 0.01. Put it. This is the thing. This is a gate question. A triangular direct runoff hydrograph due to a storm has a time base of 60 hours and peak flow of 30 meter cube per second occurring at 20 hours from the start. If the catchment area is this much, what is the rainfall excess? All are same principle and what, they absolutely no change. So volume of direct runoff is nothing but area of the triangle. Area of the triangle is half base into height basically. So that is over. The depth of direct runoff is equal to volume divided by, in the previous question he has not given the what you call it as area of catchment, right? Now in this question he is asking depth of direct runoff. So calculate it, that is over. A 252 kilometer square catchment has a 6 hour UH which is a triangle with the time base of 35 hours. What is the peak discharge of the direct runoff hydrograph due to a 5 centimeter effective rainfall in 6 hours from that catchment? So area of catchment is given, peak discharge is given, base is given. So volume is equal to, volume is directly discharge into basically what is the thing, peak discharge, it is height into basically base, that is over. Volume of runoff is also equal to area of catchment into depth of runoff actually. So that is what he has done. So this is for unit hydrograph. Next, equating for that, QP is 40 meter cube per second actually. So this is the first thing, because this is not given. So as the rainfall excess is 5 centimeters, if 1 centimeter QP is equal to this, for 5 centimeters what is QP? Linearity principle straight. So again see it. So one problem, area of catchment you have found out. One problem, you have find out depth of direct runoff. In the third problem, you are finding out what is QP, what is the peak discharge. So say equations are same. Once again you tell me basically area of under UH is nothing but the volume of direct runoff, right? The volume of direct runoff is also equal to the area of catchment into 1 centimeter, right? This is one equation, this is another equation. If you equate these two, you get whatever you want. So please refer to the Engineering Hydrology by Rajesh Srivastava and Ashu Jain, H.M. Raghunath and Manish Kumar Goyal, apart from your regular textbook and reference books. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.